Welcome everybody, Mr. Vidich here. Today we're going to talk about greatest common factor and lowest common multiple word problems. In the past few classes you've been learning about how to find out the greatest common factor and lowest common multiple, and many of you have asked how is this information going to be helpful. So today we're going to look at some real examples where the greatest common factor and the lowest common multiple will help us solve our problems here. So let's just jump right into it and look at the first question here. So the first question says, Kiara baked 30 oatmeal cookies and 48 chocolate chip cookies to package in plastic containers for her friends at school. She wants to divide the cookies into identical containers. So that's really important here. She wants each container to have to be the same. In other words, each friend's going to get the same amount of cookies. And then here, so keep going. So that each container has the same number of each kind of cookie. If she wants each container to have the greatest number of cookies possible, how many plastic containers does she need? Okay, so how are we going to do this so that each container has the same amount of cookies and there's no cookies left over? Okay, so the solution here is going to be the greatest common factor. So finding the greatest common factor between the two types of cookies, 30 and 48, will help us solve this question here. So I'm going to jump right into it and use the prime factorization method for finding GCF. So starting with 30, I'm going to do my factor tree, and 30 factors into 2 times 15, and I'm going to circle the 2 because it's a prime number, and then the 15 further factors into a 3 and a 5, and both of these are primes, so I'm going to circle them. 48 over here factors into 6 and 8, and the 6 further factors into a 2 and 3, and the 8 factors into a 2 and 4, and the 4 factors into a 2 and 2. So I'm going to circle all my prime numbers so I can keep track of them. Okay, after I've done that, I'm going to list them all underneath here. So 30 equals 2 times 3 times 5, and 48 equals 2 times 2 times 2 times 2 times 3. You'll notice here I'm doing them in order of from the smallest to the biggest, just to help me keep track of all my numbers. Okay, now we need to find the greatest common factor, and in order to do that, we're going to find all the factors that are common to both numbers. Well, I see a 2 here is common to both, so I'm going to list it over here. I'm running out of room here, so I'm going to try and do it way over here. So 2 times, and is there another common number? Well, I see a 3 over here, and I see a 3 way over here, so I'm going to circle both of them and put the 3 over here. Now the 5 I'm going to cross out because there's no 5 underneath, and all these 2's are extra, so I'm going to cross them out. They're not common to both. So really, I only have the 2 and the 3, which when multiplied together gives me a 6. So that is my greatest common factor. And how does this help us with this question? Well, that is the number of containers that she's going to that are going to hold all these cookies. So in other words, I can take my 30 oatmeal cookies and divide them into groups of 5. So let me do a visual diagram here so everybody kind of understands what's going on here. So if I take my 30 oatmeal cookies and divide them into groups of 6, I'm going to have 5 cookies in each container. So there's one container, there's the second container, And bear with me here until I get all my dots out. Each dot is a cookie. That's 4. And then finally, the 6th container is going to have also 5 cookies. So we can see here that each of these is 1 container, 2 container, 3, 4, 5, and 6. Okay, and then I'm going to do the same thing for the 48 chocolate chip cookies, and I'm going to do those in black. I have a feeling I might run out of room here because each container, when I divide 48 by 6, I'm going to get 8 chocolate chip cookies in each container. So I'm going to try and do this a little bit faster here so we don't run out of time here. So 1, 2, 3, 4, 5, 6, 7, 8. That's in one container. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Whew, that's a lot of cookies. Okay, so we have now in each, you can see here in each container there are 8 chocolate chip cookies and 5 oatmeal cookies, and then so on like this. So each container. So really, the only way she can do this equally without having any cookies left over is to have 6 containers, which means 6 lucky friends are going to get some cookies. Okay, let's move on to the next one. And here we have just some pencils here. And pencils, when you go buy pencils, they come in a package of 10. And you also want to get some erasers. So erasers, however, come in a package of 12. So not quite 1-to-1 here. So let's see what our problem is. So Philip wants to purchase the smallest number of pencils and erasers that will have exactly 1 eraser per pencil. Okay, so let me just explain this if you're not clear here. And I'm going to do a visual diagram to help it make it a little bit clearer. So if we have 10 pencils, so there's one package of 10 pencils, and we have another package down here of 12 erasers. So now if we and Philip's goal is to have 1-to-1. So for every pencil he wants to have 1 eraser. So if he buys another package of pencils, he's now going to have 20 pencils. But now that's way more than the erasers, so he's going to have to buy another packet of erasers, and that'll give him 24 erasers in total. So he needs to get some more pencils, and that'll give him 30 pencils. And if he buys another pack, that'll give him 40 pencils. Let's move back down to the erasers. So if he buys another pack of erasers, he's going to have 36 erasers. And if he buys another pack of erasers, he's going to get 48. And if he buys another pack of erasers, he's going to have 60. Okay, so we need to buy a lot of pencils and erasers here to get it to be 1-to-1 here. So if he buys another bag of pencils or package of pencils, he'll have 50. And finally, when he buys his 6th bag of pencils, he's going to have 60, and then finally he's going to have an equal number of pencils and erasers. So that's one way to do this problem. But that might take a really long time if we have really big numbers. So I'm going to do this problem again using prime factorization here. So let's just jump right into it and factor out 10 and 12. So the 10 factors into a 2 and 5, and both of those are prime, so I'm going to circle them. And the 12 factors into 2 and 6, and then a 2 and a 3. So you've probably figured out by now that I'm going to need to use the lowest common multiple in this case to get my answer. And we can see here that the lowest common multiple is going to be 60 eventually, but let's just do it using the prime factorization method and see if we get the same answer. Okay, so let me rewrite this down here as 10 equals 2 times 5, and 12 equals 2 times 2 times 3. And remember, for the lowest common multiple, the strategy for getting the lowest common multiple is a little bit different than the greatest common factor. So it's similar, but with a bit of a twist here. So again, I need to look at a 2 here, and I'm going to take my 2 and multiply down here. But when I take my 2, I need to cross out another 2 in the other number. Okay. Then I look at my. In other words, you know, if there's 2 of one number, we only take 1. Okay. And I see a 5 here. I'm going to circle it. So unlike the greatest common factor where we would cross the 5 out, in this case we take the 5. We take all the unique numbers. 5 here, and this 2. And you might be asking yourself, why did I not cross this 2 out? Well, this 2 is actually unique because it's the second 2 in the factors of 12. So I'm going to take it. It's actually unique. And then the 3 is also unique. So I'm going to take it as well. So you take a lot more numbers than when you do the greatest common factor. And so when we do this, 2 times 5, I get 10, times 2 is 20, times 3, and if you do this all on your own here, you should end up with 60. And there we go. So we get the same answer using the visual way of doing it, drawing it all out, or we can use prime factorization and we'll get the same answer. Okay, let's move on. Let's do a few more examples. So example number 3, we have boxes that are 12 inches height, 12 inches tall, are being stacked next to boxes that are 18 inches tall. So what is the shortest height at which 2 stacks will be the same height? So if we do another visual diagram, what we get here, I'm going to do it over here. I have one box, and that box is 12 inches, and I have a slightly bigger box that is 18 inches. So again, we could do this, drawing it all out, but it might take us a really long time. But let's just do it anyway here, just to see if we get the right answer. So if I put another box on top of this, I'm going to get a total height of 36 inches. And if I put another box, another 12-inch box on top of this one, I'll get 24. And if I put another box here, I'll actually get 36. So there we kind of see that we need 3 of the smaller boxes, and 2 of the bigger boxes to get the same height here. Okay, but let's do that using prime factorization. So it's again, you'll see, you've figured out that this is a lowest common multiple problem. So let's do that first. Okay, so we have 12 and 18 as my 2 numbers. 12 factors into 2 and 6, and 6 factors into 2 and 3, and those are all prime. So I'm going to circle them. 18 factors into 2 and 9, and the 9 into a 3 and 3. So I'll circle all of these here, and underneath here I'm going to write out 12 equals 2 times 2 times 3, and for the 18 it is 2 times 3 times 3. Okay, so for the lowest common multiple, again, we take all the special ones. We take all the unique ones. So let's start with 2, and we're going to cross this 2 out because it's no longer unique or special. We're going to move on to this 2 and take it. And I don't need to cross anything out. And then finally take the 3 here, which makes this 3 not so special anymore. But this 3 is unique because it's the second 3 in the factors of 18. So my numbers here are 2 times 2 times 3 times 3, and I'm hoping I get 36. So let me see here. 2 times 2 is 4. 4 times, let me do this with a little pointer here. So 2 times 2 is 4, times 3 is 12, and 12 times 3 is indeed 36. So there's 2 ways of solving this problem. Okay, last one of the day here. And let's see if we're going to use the LCM. Let me write it down here. LCM or GCF. Let's see what this problem is. Okay, Tim has a bag of 36 orange flavored sweets, and Peter has a bag of 44 grape flavored sweets. They have to divide up the sweets into small bags of equal number of sweets. In other words, each bag is going to contain either orange flavored or grape flavored sweets only. Okay, so this problem is very similar to the first one we did with the cookies. And the goal here is to have no extra sweets and finding the largest possible number of sweets in each bag. So again, now I think here we're going to get we're going to do the greatest common factor and find the number of bags that we're going to hold all our sweets together without having any extra sweets hanging out. All right, so this is gonna, again, we'll jump into prime factorization here. So 36 and 44. 36 factors into a 6 and 6, and a 2 and a 3, and a 2 and a 3. So circle all of these. Okay, 44 factors into 4 and 11, and 11 is a prime, so I'll circle it right away. 4 factors into 2 and 2, and that's it. So underneath here, I'm going to write 36 equals 2 times 2 times 3 times 3, and 44 equals 2 times 2 times 11. Okay, because we're doing greatest common factor, and how do I know it's the greatest common factor? Because I'm trying to divide up the sweets into smaller packages, into smaller bags here. So I know my number is going to be smaller than the 36 or 44 in this case. If I was to do lowest common multiple, I would end up with a really big number, and I certainly don't have that many candies around or sweets. Okay, so the first, so to get the greatest common factor here, I take my 2's are common, there's another 2 that's common, and then there's no 3's in the bottom number, and there's no 11 in the top number. So it's just 2 times 2, which in this case is 4. So what does that mean? Well, that means that they're going to have 4 bags, 1, 2, 3, 4 bags, and in each bag we're going to have 9 orange flavored sweets and 11 grape flavored seeds. So I take my original numbers and I divide each one by 4, because that's my greatest common factor, and I get that's how I get my numbers of 9 and 11. So let me just do this for one bag here. I'll draw it out here. So in this, in the first bag, I'll get 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 orange flavored candy, and 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So each of these bags, number 1, number 2, number 3, and number 4, are going to contain 9 bags of orange flavored sweets and 11 grape flavored seeds. Okay, that's it for now. Thank you for watching, and see you next time.